All right, let's talk about an element that is, believe it or not, all around us. It's even inside of us, but it just doesn't get the same attention as, say, gold or oxygen. It's a key ingredient in everything from major industrial chemicals to the very proteins that make us who we are. So today, we're going to pull back the curtain on the absolutely fascinating world of sulfur.
So to kick things off, I've got a little riddle for you. Picture these three things in your mind. You've got a volcano, just erupting with massive force. You've got the natural gas that might be heating your home right now. And then you have, well, your own body. What on earth could possibly tie all of those things together?
You guessed it, it's sulfur. That's the answer. It's the quiet, unsung hero connecting them all. It's not just some random chemical, it's a fundamental building block of our planet. And get this, it's a critical piece of the proteins that are absolutely essential for life as we know it.
Okay, so if it's so important, where is all this sulfur anyway? Let's take a little tour of where this element likes to hide, often right under our noses.
I mean, this stuff is pretty much everywhere. You can find it deep underground as these beautiful, pure yellow crystals. It's also locked away in metal ores, things like iron and zinc. It's in minerals like gypsum. And of course, it's a huge part of volcanic gases. That's where you get that classic, not-so-pleasant rotten egg smell. It's also in natural gas, which is actually why the gas has to be purified. And like we said, it's a critical part of us, building the very proteins in our bodies.
So how do we get our hands on all that pure sulfur that's buried so deep underground? I mean, it's way too deep for a regular mine. It presents this massive engineering puzzle. So, how do we solve it?
Well, the solution is just brilliant because it's so completely counterintuitive. Instead of trying to dig up a solid rock, you just change its state. The entire idea is built on this one simple, powerful concept. If you can't dig it up, melt it, and then pump it to the surface like water.
And just how you melt it? With superheated water. Yeah, we're talking water that's heated under pressure to 170 degrees Celsius. That's about 338 degrees Fahrenheit. So way, way hotter than the normal boiling point you're used to.
This whole thing is done using a method called the Frasch process, and it is seriously clever. Picture three pipes, like a straw inside a bigger straw inside an even bigger straw. They send this whole setup deep underground. That superheated water gets forced down the outermost pipe, and it melts all the solid sulfur into a big pool. Then, and here's the magic, compressed air is shot down that tiny little pipe in the very center. That air pressure churns up the liquid sulfur, turning it into this light, airy froth that gets forced right back up the middle pipe, all the way to the surface. It's like a heist, deep underground. Now, the most incredible part of all this is the result. This process doesn't just get this sulfur out of the ground. It delivers it in an unbelievably pure form. We're talking 99.5 to 99.9% pure, basically ready to go right out of the pipe, no extra steps needed. It's a mining and a purification process all rolled into one efficient, ingenious step.
Okay, so now we know where sulfur comes from, but what makes it so special on a chemical level? Well, to really get it, it helps to compare it to its much more famous chemical cousin.
Right, so sulfur sits just below oxygen on the periodic table. They're in the same family. And just like oxygen, it loves to grab electrons and form a negative ion. But here's the critical difference, the thing that changes everything. While oxygen pretty much always has a negative charge, sulfur is way more flexible. It can also have positive oxidation states, which you can just think of as its electrical charge. This ability to kind of play for both teams, electrically speaking, lets it form a huge variety of compounds, and that versatility is the key to why it's so useful. Another really cool thing about sulfur is its ability to form what we call allotropes. All that means is that the same element can link up its atoms into different structures. So at room temperature, the most stable, common form isn't just one sulfur atom, S. Nope. It's actually a little ring of 8 sulfur atoms all bonded together, which we write as S8. It's this beautiful 8-membered ring structure that gives solid sulfur its distinct crystal shape.
So, let's bring all of this home. From deep earth mining to its unique chemistry, what are the big takeaways? Why does this overlooked element matter so much?
The story of sulfur is just amazing when you think about it. First off, it's just everywhere, a true cornerstone of our planet and our own biology. Inside our bodies, it forms these special links called disulfide bonds that literally fold our proteins into the exact 3D shapes they need to work. Second, the way we get it is a total testament to human ingenuity, melting it with super hot water miles beneath our feet. And finally, that chemical double life it leads makes it this indispensable ingredient in just a countless number of applications.
You know, the origin story of sulfur, with its extreme temperatures and pressures deep inside the Earth, It's a powerful reminder. It really makes you wonder, doesn't it? What other materials that we use every single day, without a second thought, have origins that are just as extreme, just as wild, and just as fascinating?